Welcome everyone. So in this video lecture we will start a new chapter in class 9th physics, which is force and laws of motion. Okay. The term force, I think everyone is familiar with this term force, right? Like in our daily common language too. Okay. The motion. Now this term I believe everyone is familiar with now, because in the last chapter we studied how to describe a motion. We studied about speed, velocity, distance, displacement, acceleration. So we studied quite a bit about motion, so we know how to describe a motion. Now in this chapter, what we will learn is what causes motion, like why the motion is happening. So that question we will try to answer in this chapter. If I want to take some examples from our daily activities, or if you just look around, then you will find these examples quite often of forces. For example, this person on the wheelchair, as he is trying to move forward, he is applying some force on the wheel to do that, right? If I want to kick this ball, I need to apply some force. As this car is moving forward, its engine is applying some force to make it move forward, right? This person, as he is riding a bike, he is applying some force to move forward. Similarly, this police inspector, he is also running forward, applying some force to do that. So you will see these examples of force everywhere. I would say at this moment, take a 5-minute pause, try to point out some more examples of force, right? And in the comment section, if you can, please provide your examples so everyone can learn from it. Okay. So now, as we know, as I was telling before, is we all are familiar with the word force, right? But still, I think there is a need to explain it. So I'm not going to spend too much time on defining force, but I think I will spend some time on talking about force, giving some of the definition of the force, characteristic, some of the properties, so that everyone who knows it, it's good for them, it's good revision. Who doesn't know it, they will also be on the same page as everyone else. Okay, so let's start. What is force? Okay, so if I want to give a scientific definition of the force, so force is a push or pull upon an object resulting from the object's interaction with another object. Okay, that's a lot of definition here, but basically what it is telling us, force is resulting from an interaction between the two objects. Whenever there is an interaction, there is a force, and once an interaction goes away, the force goes away. So this example what we have here, where the person is pushing a car, there is an interaction between the person and the car, so there is a force. Now let's say this person is standing here and the car is here, and then I say, is there a force between the car and the person? You will say, well, there is no interaction, right? So force also ceases. So that's typically the way to think about force, that force is resulting from an interaction between the two objects, and once an interaction is gone, force is gone. Okay, let's move forward. The standard unit of force is Newton. Okay, so in the questions you will see this very common, that calculate the force in Newton, or they will give you a force and they'll talk about calculating something else, and the force value would be in terms of Newton. So standard metric unit of the force is Newton. It's just something to remember, right? And 1 Newton, just to understand what does Newton means in terms of the units we already know, 1 Newton is 1 kg meter per second square. Okay, so this is just to convert the Newton into something we already know. We know about kilograms, we know about meter, we know about second, right? So 1 Newton is equivalent to 1 kilogram meter per second square. You may also think of 1 Newton is the amount of force required to move an object of 1 kilogram by acceleration of 1 meter per second square. Okay, so 1 Newton of force is equivalent to amount of force required to move an object of 1 kilogram by 1 meter per second square. And we will learn in as we move forward in this chapter that how that is true. But for now, I would say remember that standard unit of force is Newton, and 1 Newton is equivalent to 1 kg meter per second square. Okay, let's move forward. The force is a vector quantity, and I believe at this moment, based on whatever we have learned so far, everyone should know what does that mean. The vector quantity, that means force has a magnitude and direction, right? That is what we know from our previous lectures. Any vector quantity can be completely defined if you define its magnitude and direction. So one quick example, as this person is pulling the car and applying some force, let's say he's applying the force of 10 Newton. Okay, now if I say like this person is applying the force of 10 Newton, that will not be enough, because then you will ask the question, okay, well, he can apply the force in this direction, in this direction, in this direction, in this direction, or there are all the infinite number of direction where this person can apply the force. So in this example, the person is applying the force 10 Newton to push the car backward. Once you say that, like the magnitude, which is the 10 Newton, and the direction, so in this case it would be west, right? So once you say that, like 10 Newton of the force in the west direction, that's how you define it. So force is a vector quantity. It needs both magnitude and direction. So let's recap what we have learned so far. Force is a result of an interaction between the objects, right? The unit of the force, standard metric unit of force, is Newton, and force is a vector quantity. Okay, all right, so in the next chapter we will study about balanced and unbalanced forces. Till then, bye.